Hello everyone. So here we are for a physics activity. As you can see, it has given draw a plot showing the variation of electric field E vector with distance r from for a uniformly charged thin spherical cell. Okay, so we will see the variation of electric field with the distance r at which an electric field is to be calculated for a thin spherical cell. Okay, so we all know, okay, first let's suppose here we are considering a thin spherical cell, okay, having center at O with radius R, clear, and let Q be the total charge of the thin spherical cell, okay, clear. Now there are three cases. One is for an inside point, let the distance be r, okay. Another is for an outside point when the distance is r. We are taking the distance of the point of observation r in each case, whether it is for inside point or for an outside point. The distance is remaining same, okay, getting my point? So now we all know that electric field at an inside point for a thin spherical cell is equal to 0 because there is no charge inside a conductor, correct? Similarly, electric field at an outside point at a distance r from the center of the sphere or spherical cell is given by 1 upon 4 pi epsilon 0 q upon r square. Okay, so now from this thing we can say electric field on the sphere, that is on the surface of the spherical cell, is given by 1 upon 4 pi epsilon 0 q upon r square. At this case the radius is equal to the distance of the point of observation. Okay, clear. Now we will see this in a graphical manner. Suppose we are taking the electric field along y-axis and the distance r along x-axis. Okay, now suppose the center of the coordinate axis is coinciding with the center of the spherical cell. Okay, so now as we know that for an inside point electric field is 0, so if I consider an inside point, the electric field will be 0 for throughout. Okay, clear. Now for an okay, let's discuss for the on the surface case first, that is q upon r square times 1 upon 4 pi epsilon 0. Now at this surface there is, we know that r is equal to r, that is the radius of the surface, right? So at this point we are getting the maximum value, so the electric field will be given by this. That means it is being maximum when the point of observation is same as the distance of the radius of the sphere. Okay, now for the outer side point it is varying with the square of the distance inversely. That means for an outside point E is inversely proportional to r square, which can corresponds to a rectangle hyperbola, correct? So the variation will be shown as like this. So this is for an outside point, this is for on the surface, and here it is for inside point. That means the variation we can see as this. These are the variation of electric field with the distance of the point of observation for a spherical cell. I hope you all get it. Thank you.